Okay, so we're looking at, this is topic 4-4, and this is talking about tangents. So let's look at the tangents. Remember, a tangent is a line that intersects a circle at a single point. So the naming of this tangent, the only tangent line in this picture is tangent line TX. You could also call this line XT. Remember, when you name a line, you pick any 2 points on that line, you can name that line with those 2 points. But you got to have the correct symbol. Notice it's got 2 arrows because lines extend infinitely in 2 directions. So along with that, we also have the point of tangency. And the point of tangency is the point where the line is actually tangent to the circle. Just like we talk about in class, how I constantly go off on tangents. The point of tangency is where the line leaves the circle. Imagine if you're driving in a car and you got something stuck in your tread and your car tire's going around, round and round, and all of a sudden it kicks that rock out, and that person behind you is the one that gets the rock in the windshield. It always leaves at a 90-degree angle, which we'll talk about in a little bit. So our point of tangency is actually point T. Point T. Or you could just call it T. I'm not being very picky. Alright, so let's look now for a point on the interior of the circle. Now remember, the interior of the circle is exactly that. It's the inside of the circle. This is the interior right here. This is the interior. So the blue represents the interior of the circle. So if I'm looking for 2 points on the interior, I would have point I and point P. So you can write it as point I and point P, or you could just write I and P. I'm not going to be very picky, okay? So now let's look for the point that's in the exterior of the circle. Whereas interior is on the inside, exterior is on the outside. So here's the exterior of the circle. All of this is exterior. Well, the only point we actually have in the exterior is point X right here. So that would be point X. Now point X is exterior. Why is point T not exterior? Well, point T is actually on the circle. Exterior means outside the circle. So whereas P and I, private investigator, that really wasn't funny, but I said it anyway, are inside the circle, point X is on the exterior of the circle. So T is on the circle. So this is the only one we have. So those are your interior and exterior points. So now let's look at this theorem we got. And I'm getting very good at adjusting all this. Okay, so we have this theorem here. And what the theorem says is if a line is tangent to a circle, and the marker is terrible and doesn't work, so guess what? I just chunked it. Hopefully you could hear that. Let's try a different one. So if a line is tangent to a circle, that means it intersects it at one point, then it is this big word here, perpendicular to the radius drawn at the point of tangency. So if I'm looking at this picture here, perpendicular means intersect at 90 degrees. So what this is saying is if I've got this tangent line BA, okay, that's my tangent. I'll label that as such. Okay, that's my tangent line. And then I'm going to draw my radius. My radius, remember, is the segment that comes from the center of the circle to a point on the circle. So here's your radius. What the theorem says is that radius and tangent that intersect make a 90-degree angle. So there's your right triangle. So this example says if this is a circle with center C and the AB is a tangent, find X. And don't put right there. I can see X. You don't have to tell me it's right there. I can find it.
What are you getting?
I'm busy, honey. Please go. So if I want to find the point on the, if I want to find X, I will get you water in a minute. Go away. You're going to get in trouble. So, see, I'm a nice mommy, aren't I? So if I want to find point or the length of X, what I have to do first is I have to do the Pythagorean theorem. This is a right triangle. So I'm going to use, if it comes back in here, I swear, a squared plus b squared equals c squared. Well, I know a is 5, so I've got 5 squared. B squared is my tangent, which is 12 squared. And c squared is this side right here. So let's find out what the whole side should be. 25 plus 144 equals c squared. Then I'm going to add those together, 169, no bad jokes here, equals c squared. And then I'm going to square root. Remember, square root is the inverse operation of squaring. Okay, the inverse operation of squaring. So square root of 169 is 13. So that's c. Now c is the length of the entire segment. But I don't want the entire segment, I just want x. But what do I know already? This entire segment is comprised of a radius. Isn't there another radius here? So that radius piece is 5. So if the whole thing is 13 and the radius is 5, how do I find x? Well, 13 is the entire side, minus 5 is 8. So therefore x is 8. So that's how we use the perpendicular for the theorem for the tangent. So remember, a tangent and a radius are perpendicular to each other.